mother in a cottage. The little girl's name was Little Red Riding Hood, as she wore a beautiful red cape and gown that was knit by her dear, dear grandma. One day, her mother gave her a basket of goodies. "Take this basket of goodies to your grandma's house. She's not feeling well." "Okay, Mom. And make sure that you don't stop to talk to any strangers along the way." "Okay. I'll see you soon." So Little Red Riding Hood set on her way. As she went, she saw beautiful sights, but the most beautiful thing she saw was a huge field of wildflowers. "I should pick these flowers for Grandma. She would love them." So Little Red Riding Hood continued to pick the flowers. From far away, a big bad wolf saw her picking the flowers. "Ooh, I should go speak to her. She looks delicious." So as the wolf approached Little Red Riding Hood, she said, "Hello, who are you?" "I'm a wolf." "Who are you?" "I'm Little Red Riding Hood." "What are you doing, Little Red Riding Hood?" "I'm picking these flowers for my grandma." "What a great idea. You should pick a big bunch of them so you can make a huge bouquet for her." "That's a great idea, Mr. Wolf. Thank you." So Little Red Riding Hood continued to pick the flowers as the wolf got a great idea in his head. He set off to Grandma's house, ready to go. As he went to Grandma's house, he knocked on the door, and Grandma answered, "Hello." "Hello," and he pounced on her. The wolf decided to eat the grandma whole. As he finished eating Grandma, he decided to take her dress and gown and sit in her bed, waiting for Little Red Riding Hood so he can get the second part of his meal. And he waited. Sooner or later, Little Red Riding Hood came to the door. "Hello, Grandma!" But nobody answered the door. She slowly creeped her way in and saw Grandma sitting on the bed. What is Grandma doing on the bed? The lights were dim, but she could still make out somewhat of Grandma. "Why, Grandma, what big eyes you have!" "The bigger the eyes, the better I can see you with, dear." "Why, Grandma, what big ears you have!" "The bigger the ears, the better I can hear you with, dear." "Why, Grandma, what big teeth you have!" "The bigger the teeth, the better I can eat you with, dear." The wolf decided to pounce on Little Red Riding Hood, but before he could do that, she decided to run off screaming. "Ah!" She left the house, and as she left, she saw a big axeman along the way. "Help! Help!" The big axeman decided to follow her into the house and saw the wolf in there. The big axeman decided to take the wolf, open his stomach, and save Grandma. And there she popped out. Little Red Riding Hood was so happy. Yay! So she hung out with Grandma while the axeman took the wolf and killed him. After that, Little Red Riding Hood, Grandma, and the axeman all decided to eat the basket of goodies together. The axeman took Little Red Riding Hood home and gave her to her mother. She said to her, "Mom, I will never ever talk to strangers ever again." And they all lived happily ever after. The end.
Hello, boys and girls. Now, as you saw from Little Red Riding Hood, that was a story all about food. So Miss Erin and I decided, let's have some food experiments and learn a little bit about kitchen chemistry and food science. So when we're thinking about kitchen chemistry, there's a couple of different things we're talking about. One thing we can do with food is we can make a mixture. Now, a mixture happens when you have two separate things and you combine them together, yet they still keep their own separate properties. And a great example of that involves salt and pepper. And people think that salt and pepper go together so well, and maybe they do, but in this case, maybe they don't. So I'm going to pour some salt into this clear cup. Here's my salt. Now I'm going to pour in some pepper. Okay. And I'm going to shake, and I'm going to stir, and I'm going to shake some more. And I think I put more pepper than salt in, so here we go. And then, oh, it's still very separate. And I'll tell you what, boys and girls, we'll get a close-up on this. As you can see from that, you could still see the salt the little grains of salt. You could still see the grains of pepper. Completely separate, yet combined. So that's what we call a mixture. Now, let's talk about a solution. A solution happens when something that is solid gets put into a liquid and then it dissolves. So now we're going to take our friend water, and I'm going to add a little bit of sugar. Now, sugar looks a little bit like salt but tastes very different. as you probably know. So let me get a teaspoon of this sugar. And I'm going to dump this into the water. And now we're going to stir, stir, stir. We're going to shake, shake, shake. And now I'm going to come closer. And you're going to see what I've made. It looks completely like clear water, but if you tasted it, it would taste very sweet because it's now sugar water. And the sugar is completely invisible because it is dissolved into the water. And for that reason, we call the sugar soluble, which means that it's going to be absorbed into a solution. So we have one last thing that we want to talk about when it comes to kitchen chemistry. And this is a reaction. A reaction happens when you take two very different things and you combine them and you get a totally different result. So there's a very favorite kitchen reaction that I love to do, and you can do this very easily at home, and this involves baking soda and vinegar. So I'm going to scoop some baking soda right into my cup. I'm going to put a nice heaping teaspoon in. I'll put a little more in. Why not, right? Okay, and now we're going to pour in the vinegar. So what do you think is going to happen when I add this vinegar? In science terms, we call that making a hypothesis. So I want you to make a hypothesis and think, what's going to happen to this baking soda? Are you ready to see? Let's go for it. Here we go, folks. Whoa! Oh boy. Oh boy. So there we go. That even turned out better than I thought. So what we made was a completely different product. The vinegar combined with the baking soda, and we had a little bit of an explosion. And you can do that at home. Just make sure you check with your grown-up first. You don't want to make a complete mess of the kitchen. And that, my friends, is the difference between a mixture, a solution, and a reaction. Now, why don't we learn about a different science concept? Stay tuned.
All right, boys and girls, we are back, and I'm here to show you an experiment about absorption, which we talked about a little bit in the beginning. So what I have to do this is I had a packet of Jello mix. You can use any kind of gelatin. Jello mix like this is super simple. It can be any flavor that you want. We're going to make awesome gumdrops. So what you're going to do is pour your packet of Jello mix into either a cup or a bowl, just like this. And you're going to need a cup of water, an eyedropper, or if you don't have one of these, you can use a straw. You just have to make sure you have a grown-up's help, or you pay very, very close attention as you drop water drops into the Jello mix, because it requires a lot of focus, because you have to add one drop at a time. So you'll see that I'm just going to add one drop of water. That's it. Do you see it? There's my drop. In the same spot, I'm going to add a couple of more. You can watch as the water gets absorbed into the Jello mix, drop by drop, in the same spot. A couple more, 8 drops. So I'm going to let it sit a minute. It should be absorbed. Even if I move it around, you can see that what I created doesn't move. It stays solid. It becomes a solid. And then I'll take a spoon and I'll just take it out with my spoon. And I made a really awesome gumdrop that you can actually eat. So you can make your own gumdrops at home just like this to play with or eat or whatever you want to do with them while exploring the scientific concept of absorption and watching as water absorbs into the Jello mix and creates something very awesome and yummy.
Hello again. We've been talking about density. Now I'm going to show you an experiment about density that we can make a rainbow in a jar. Here is our jar, and this is what you start with, just a nice clear plastic jar, or a nice clear glass jar. It doesn't have to be anything fancy. It could be an old spaghetti jar that was washed out really well. And what we're going to start with, we're going to make some different solutions. The first thing we're going to do is we're going to make a purple layer. And we're going to start with our densest layer. And this is corn syrup. Corn syrup is very dense, denser than water, denser than olive oil, denser than dishwashing detergent and dishwashing liquid. And you will see, this is brand new corn syrup, so I gotta open it. Okay, and I'm gonna use a half a cup. For everything that we're doing today, we're gonna do a half a cup of it. So that way our layers are gonna be nice and even. Okay, so here's our half a cup of corn syrup. I'm gonna pour it right into this cup. And I'm gonna make this layer purple, which happens to be my favorite color. Now, does anybody know what we're going to do as far as food coloring goes? What are we gonna add in order to make the color purple? Do you know? That's right, we're gonna put a little bit of red. 2 drops of red, and now 2 drops of blue, and now we're going to shake it all around. Sarah, could I have a spoon? Let's see, it's really, this is so dense, this corn syrup. It's all sitting right on the top. Here we go. I'm giving it a nice stir. Ooh. Really cool looking. All right, we come closer so you can see our purple corn syrup. All right, and now I'm going to pour this into the jar. All right, here it goes. So while this pours, I'm going to kind of leave this here to try to drain out. It's kind of going slowly. We're going to work on our next layer, but we need to reuse the measuring cup. So I'm kind of sort of getting out the corn syrup. The problem with corn syrup is it's extremely sticky. And really, this is kind of a job for some dish soap, which is what we're going to use next. So now I have some dish soap, and in this case it's blue dish soap. I'm making a half a cup, which turns out to be basically what I have in this little jar. And now I'm going to pour this carefully into my jar. Okay, and now I'm going to clean the measuring cup out again. And let's see what's next. Next, it's going to be water. So we're going to need, and make sure everything's out of here. The last layer got kind of funky. Should I redo this?
No, I think
Can you see 2 distinct layers though? Yeah, I guess you can. Yeah. I cut that out when you let it. All right, and now we're going to we're going to add water. So water is the next in our ladder of density. So I'm going to put a half a cup of water. Measure that out. Measure better than I just did. It's better if you have a liquid measuring cup, but we don't. We're sitting here at the library. Okay, so I have my water in here. I'm going to make this green. So let's add a couple of drops of green food coloring. Here we go. And with food coloring, I have to be honest, a little goes a long way. You don't need a ton, just a little bit. 1 or 2 drops always seems to do the trick. Okay, and now I'm gonna put our layer of green in. And again, this is the water. And when you pour, just try to go as gently as you can. All right. And now our next layer is going to be yellow. And yellow is kind of sort of the easiest layer. It's going to be olive oil. So now I'm going to measure half a cup of olive oil. And I don't even need to put this in a separate glass because olive oil is yellow on its own. And in it goes. Okay, so that's our yellow layer. And now we're going to do our final layer. And for this, we are going to use rubbing alcohol. Here we go. Just regular rubbing alcohol that you probably have up in your bathroom in your medicine cabinet. And let's see. I have a funny feeling, folks, that this also has not been opened yet. Here we go. And this I will have to mix up in a separate cup because we're going to make this layer red. We've added the red layer and now we're done. And this is the problem. It's hard to see these layers in the lighting of this room. So I'm going to go by the window and Miss Erin's going to come with me. And yes, I have my mask on now because Miss Erin and I are close together. Let's see, Miss Erin, how's this? Can we see it? You know, I think here at the Fairlawn Library we need professional equipment. I can tell you this, it worked and it's super cool. And this is something you can do at home and make this rainbow. One idea, one suggestion though, don't jump up and down with it because then everything will kind of mix together. And instead of all of these density layers, you're gonna have one big solution. So we don't want that. We want to look at the density. All right, thanks guys for sticking with me and try the rainbow in a jar. Okay, people, now we're going to stick with eggs, but we're going to do this a little bit differently. We're going to see what happens when we take an egg and we soak it in vinegar. In this case, I used hard-boiled eggs, and I took 2 hard-boiled eggs and I covered them with vinegar, and I wish I could kind of show you what this looked like when I first dropped them, because once I put them into this bowl, the vinegar, kind of the acid in the vinegar attacked the eggshell of the egg. And the eggshell of the egg is made up of calcium. And the acid attacked the calcium, and you could see all these little bubbles as the vinegar was doing its work, creating a little reaction, and it eventually wore away the entire eggshell. And I'm going to open this up and I'm going to show you what this looks like. But before I do that, I want to tell you, you can also do this experiment at home with a chicken bone. You can take a chicken bone and soak it in vinegar, and then the bone becomes like a rubber bone. It becomes super wobbly because your bones are made up of calcium. And that's why we drink lots of milk, so we can have nice, strong bones. But if you don't have calcium, your bones get very floppy. So we do not want floppy bones. And you can see that with the chicken bones. But now, let's take our eggs out. And I'm going to tell you the truth. I haven't taken it out yet. But this is really crazy. This has absolutely no eggshell. And if you look at my vinegar, this was completely clear vinegar. And now it's just kind of murky because it's taken the calcium from the eggshell and it's it's just changed the whole consistency of the water. Now, this is telling me that this should bounce like a ball now that it's been soaking in the vinegar. So let's see if this really changes the makeup of the egg. No, it didn't really bounce like a ball. I'll say this though, it didn't break. Okay, Miss Erin, can you get me? I'm just gonna do this right on the floor. Well, this is really weird. It's not breaking. It's not bouncing. It finally broke, but it's like really like kind of squishy and hard. Let's try this other one. Let's see what it does. All right, I'm throwing it. So think about even a hard-boiled egg. If you threw it on the floor of your kitchen, would it just kind of run around like that? No, I don't think it would. So it's very satisfying. So go to your kitchen, soak an egg in vinegar, watch the shell completely dissolve, and then you can make this weird thing that you can throw all over the kitchen. All right, thank you everyone. Let's see what's next. Hello, my friends. We are back, and we are going to have an experiment that talks about density. But I'm wondering, what exactly is density? Well, density is pretty much however much space something takes up. Although that's not the full picture. Weight also has something to do with it. So it's how big you are plus how much you weigh. So the higher the weight, the higher the density. So we're going to talk now about eggs. Now these are raw eggs, so if I'm a very clumsy person, if I drop one of these eggs, we might have a mess on our hands. So fingers crossed I don't do it. Now I have 2 cups of water over here. I'm going to take the first cup and I'm going to put this egg inside that cup. Now let's think for a minute. I want you to make a hypothesis. What do you think is more dense, the egg or the water? Let's see. We're going to find out. Whoa! There goes my egg. My egg sunk to the bottom. So in other words, my egg is denser than this water. How can I make this egg float? I know. We'll make a solution. And what we're going to add is salt. Now, salt is something that you see in the ocean. So your body weighs less when you're in salt water. Because this salt will actually change the properties of the water, making it very dense. I think I'm even going to add more. Let's make this very salty water. Now I'm going to add the egg to this salt water, and as you can see, it is a true solution. I'm not seeing any grains of salt. It all blended in the water, making a completely different product. I am taking my egg and I am going to drop it into the water, and let's see what happens. What? All right, I'm coming closer. It initially sunk to the bottom, and then it floated right to the top. Can you see that, folks? So in other words, with regular water, an egg is denser than the regular water. And here's my egg kind of poking out right here. But when we add salt, that solution becomes more dense than the egg, and it pushes the egg right up to float on the top. So that's why you weigh less when you're in salt water, and it's easier to float. So folks, that's it for density.
Hi everybody and welcome back. So for you, I have a little experiment that has to do with some seltzer or soda water, some raisins, and you need a cup. And we are going to look at what happens when I put some raisins in soda water. So the first thing I'm going to do is open up seltzer and soda water, and notice how you hear fizzing as soon as the cap opens up. And if you look over here, you can see that the bubbles are rising to the top. That's because as soon as I open up the bottle, a chemical called carbon dioxide is rising to the top of the water. And we're going to see what carbon dioxide does to our raisins. So I'm filling up a clear glass with soda water. What I'm going to do is, again, I'll show you the bubbles in here. You see a bunch of bubbles raised up. That's all the carbon dioxide that's being released. I'm going to drop about 12 raisins into my cup and watch what happens. Some already rose to the top. Okay, so I already put some raisins in. As you can see, they rose to the top. So now I'm going to drop more in and watch what happens to the raisins. They go to the bottom, and then they dance to the top. Who knew raisins could dance? I didn't. Look at that. But eventually, they all kind of go to the top and they float. Some are still at the bottom, and the carbon dioxide is pushing them up. You see how they dance up and down, up and down? Some eventually raise to the top. Let's see. Keep going. Look how cool that is. Super, super cool. All right. You might be wondering why this works and why our raisins dance and then eventually float to the top of the water.
And that's because we have our soda water, our seltzer water, and that's carbonated with something called carbon dioxide gas, which again, like I showed you in the beginning, it causes those little bubbles to form when the cap of the bottle is removed and when it's poured into a cup just like this. The bubbles are still here, and that's from the carbon dioxide gas. The carbon dioxide attached to the raisin's surface. So when that happens, it results in raisins floating more. So they become more buoyant, which means they float more. But they kind of go up and down, and that's also because as soon as they sink to the bottom, the carbon dioxide makes them more buoyant, which means they raise to the top. So that's why you kind of see some of them go up and down, because they're forming, or they're working with their density, which changes as soon as they're in the carbon dioxide water. So you can even see now, some of them are still at the bottom, and some are still going to the top because they're fighting, they're changing their density and becoming more buoyant in the water. And that's that. Super cool experiment that you can try at home and watch how carbon dioxide gas interacts with raisins. I'm back, and I'm here to demonstrate another example of a reaction that produces something called a substance. So what I'm going to do is I'm going to make pennies look brand new. You know that sometimes when you see pennies, they look dirty. They have tarnish all over them, and that's because they're old and worn out. How can we make them look nice and clean? You can try to use soap and water, but that won't work. Since the tarnish of the pennies is a product of a reaction, it won't come off with soap and water. It's not that easy because of all the chemicals in the environment that have tarnished the pennies over time. So how can we make them look new again? It's simple. We take salt. We're going to take a teaspoon of salt and pour it into a cup. Just like that. And I'm going to drop a couple pennies into the salt mixture. Perfect. Now I'm just going to kind of mix them around, shake, 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 mix them, mix them, mix them. You can see me mix it up close, and then I'm going to take my pennies out. What happened? Nothing. Nothing really happened to my pennies, right? You don't even really see many specks of salt. Let's see. Why didn't that work? I wonder why. Now we're going to do the same thing with the vinegar, and we're going to place 1/2 vinegar in our cup. We're going to fill up half the cup. About halfway, just like that. And we're going to drop a couple of pennies into the vinegar mixture. Add one more penny into my salt, one more penny into my vinegar. Now, we're going to pick up with our spoon and see what happens. At home, I want you to think about what you see and say it out loud. What do you see? I'll pick one up with a spoon. Did it change? No, I don't see a change in these either. Why not? Our experiment tells us that we have to put pennies in salt and vinegar, so why isn't it working? Maybe we have to combine the two to form a reaction. Let's see if that will work. So I am going to mix, I'm going to take my pennies out of vinegar. I'm going to take my pennies out of the salt for a moment. And I'm going to pour my salt into my vinegar mixture. And you can see that it becomes cloudy. So something is going on here. I'm going to mix it and mix it and mix it until it dissolves and all the salt is gone. And now we're going to see if this worked. I'm going to drop all the pennies into the vinegar. Bring this up close with my spoon. And just watch what happens. Let's see. Mix it a little bit. Let's take a penny out. Oh, it is working. It just takes a little bit of time. Let's see. I'll probably fast forward this part. Okay, I think we're ready to see what our pennies look like. So if I take a stack of pennies out of my mixture, can you see it?
Yeah, a little bit.
Do you see the pennies? They look so much cleaner. They look shinier, they look brighter, they look so different than the pennies I showed you in the beginning of this clip. So that shows us that when we combine vinegar and salt, it forms some kind of reaction that forms a substance, which is now this mixture, which cleans our pennies because it's able to get rid of the harsh chemicals that have tarnished the pennies over time. So that's something to think about and try at home to see if you can clean some pennies that you have. All right, thanks for joining me for this one.
Hello, kids of Fairlawn. I am now going to show you my absolute favorite science experiment, and this science experiment shows a reaction. I love this one so much. If you do this at home, do not do it inside or your parents will probably kill you. So you're going to want to do it outside, and it's the simplest thing in the world. It just requires a bottle of Diet Coke, not regular diet, and I find that Coke works the best, and a full pack of Mentos. Why does this work? I don't know. The chemicals in Diet Coke and Mentos work in such a satisfying way that makes the best reaction ever. So what you do is you open your Diet Coke, and now what I'm going to do is I'm going to get these Mentos inside the Diet Coke as quickly as I can. Warning, this happens kind of quickly. So I'm going to make sure my Mentos are ready to roll. Because once it starts going, I got to get the heck out of the way. All right, here we go. Ah! I didn't even get them all in. All right, hang on. Let me see if I can get the rest of them in. Still going. Oh my gosh. All right, so guys, I basically got one Mento in, and this just went bananas. I didn't even get the whole thing in. But what you can do is just keep putting in the Mentos, and it keeps just going nuts. And if you're super fast and you can get them all in at once, it is like a volcano. It's maybe the coolest thing in the entire world. And it's still kind of exploding. It's exploding, it's coming out a little less dramatically because a lot of the Diet Coke has exploded right out of the bottle. So it's a little bit of a waste of Diet Coke, but guess what? Diet Coke's no good for you anyway. So you might as well take it and create some cool science. So this, folks, my favorite science experiment, and there you go. And with that, we end food science. Thank you.